the chapter wrap up. Reviewing for your quiz on Friday. Let's take a look at page 287 and notice that it's broken up into sections, 6.1, 6.2, all the way down to 6.9 there on page 288. Now, the first two questions on 6.1, we're not going to worry about. They are questions like this, where it gives you a 4y minus 3 over, don't bother writing this down, I just want you to see this. They give you something like this until you multiply by this, multiply this out. Pretty much the opposite of what this whole chapter is about, right? We're given something and we're always trying to simplify. This is saying to do it in the reverse order, right?
They don't have the squared though. They just have y.
Right. No, I know. I'm just saying.
Oh, okay.
These types of questions were from 6.1. We're not going to worry about these types of questions.
Okay.
This is just the opposite of what we're doing. And it's great to do that. It's just, I would not worry about anything like this. I will not give you something like this and tell you to multiply or anything like that. It's good to know how to do it. We would want to know that this distributes into here and into here, that this distributes into here and into here, but that's not really the point of what we're doing. We're trying to do the opposite of this type of thing in this. I don't want to quit. I don't want to waste time on a quiz with that kind of stuff. So what we are going to be looking at are questions 3 through 6.
Mm-hmm.
Those are really good ones to look at. And one thing to notice is that that whole thing says simplify. Each one of those questions just says simplify. So in other words, that means factor and cancel things out, right? So for instance, we have I don't even want to go into that. I mean, like, yeah, that's simplifying these types of expressions is what this entire chapter has been about, right?
Uh-huh.
And so it's good practice. These are those 4 questions, 3 through 6, are really good practice questions, but kind of to build your skills. I doubt that I will give you a question that looks like that. In other words, I'm not going to give you just an expression and say simplify.
Okay.
Sorry. I'm not going to give you just an expression that looks like one of those and simply say simplify, because you're going to be doing that in every single thing that you do, right? But it's good practice so that you see something like that and stuff like that. So, however, 6.2, let's talk about 6.2. You will have at least, and so you're going to have a question involving this kind of stuff. 6.2 was adding and subtracting rational polynomials. We're going to call all of these types of expressions rational polynomials because it's easy. They're polynomials and they're rational polynomials. Okay. Now, if you remember, and so we're going to go ahead and do one of these. Let's do number 9. So number 9 is 7 over x squared minus 81. I think that's what it was. Yep, x squared minus 81 minus x minus 4 over 3x squared minus 25x. Minus 18. Okay. Now, here's the thing. And with adding and subtracting these guys, we don't have a larger context here, like equals something, right? And when you don't have this in an equation, what we're doing with this, and when you see one of these on your quiz, I'm going to tell you I might just write simplify. Or perhaps compute or something like that. And the thing is, right, what I'm asking you to do is take this and subtract off this right here, but there's no equals sign. if there were an equal sign like this, then the next steps we would take would be different than what we're doing here. In this case, there's no equal sign. I'm going to make this distinction every single time because this is what trips people up the most. When there's no equal sign and you have something like this, add or subtract something like this, there's only one way to proceed. And just like when you have something like this, what do we need to do in order to compute this right here? What do we need to have in common? We need a common what?
Denominator.
Common denominator. Okay. So that's the key to the, when we're adding and subtracting rational polynomials, we are going to need a common denominator in order to make that happen. So right now, do we have a common denominator?
No.
No. So what do you want to do first in order to get us a common denominator?
Probably factor it out.
Factor. Exactly. Because like as of right now, like I have no idea. No idea. But it's the same thing that you do if you had something like this. If you factored that guy right there, your life would be a lot easier than if you didn't, right? So it's the same principle is true with polynomials. If we factor these, maybe it'll make our lives easier. So let's do that. 7 over what? What is this? Say
X plus 9. X minus 9.
You don't sound certain about that, and neither am I. So let's check it. First gives us x times x is x squared. Outer gives us a negative 9x. The inner gives us a plus 9x. So it's the same thing, outer and inner. One's positive, one's negative, and so they cancel out. The last gives us a negative 9 times a 9, which gives me a negative 81. All we're left with is x squared minus 81. We are good to go. Now, you must remember that numerators, it's not written this way, but the numerators are in parentheses. So I would say that as you're copying this stuff down, as you start to work on it, that you put numerators in parentheses. I'm going to go ahead and say that. Put not numerators, numerators in parentheses.
Okay.
Put your numerators in parentheses. Put your numerators in parentheses. Say it with me.
Put your numerators in parentheses.
Yes, this will help you so much because it's especially on a quiz, right, or a test, because the time is a factor and you're not thinking and you're just plugging along. If you, as soon as you copy this stuff down and start working on it, you just automatically put a numerator in parentheses, could save your life right there. Okay, so now you were telling me that we needed to do something to this denominator, and what do we do to it?
Factor it out.
Yeah. And so I know that it's going to look something like this, so I'm going to go ahead and draw that out. So what should we have for first? What should my first ones be?
Of what?
Just what's the only way to get this combination right here? As far as we know.
Well, X, put an X there.
Well, X's, yes, they both have to be X's.
So it has to be a 3 and a 1.
3 and a 1. It's the only way that we know how to break these guys up. It's the only way we've talked about factoring these guys. And we're going to factor into whole numbers. Since that's the case, the only way to get a 3 is with a 3 and a 1. And so we don't need to worry about that. Now, let's just take a clue here. from the previous thing that we factored. Now, we may be wrong. We may be wrong because I don't know just right off the top of my head how to factor this guy. But I'm thinking that, well, first off, 3x plus or minus something looks nothing like either one of these. So, okay, forget that for a second. But I could certainly make this look like one of those guys by putting a what right here.
I'm sorry, you cut out.
Okay, so the hope with all of these is that we already have some kind of common factor from over here and over here. I could see that the 3x plus or minus something looks nothing like either of those because this doesn't have a 3 in front of it and this doesn't have a 3 in front of it. But I could make this guy look like one of those guys by putting what number right here?
9.
A 9, right? And so I don't know. I don't know if this is going to work, but it's my hope. I'm hoping that one of these factors will be in common. Maybe it is, maybe it isn't. Or if you don't like thinking that through, you could just brute force and just factor this guy. There's only one way it's going to factor anyway. But I'm hoping, because remember the guesswork, right? We'd have to factor 18. It could be 1 and 18. It could be 2 and 9. It could be 6 and 3, and so on and so forth. But I'm just going to hope that this guy's a 9, and maybe that'll help me out. If it is a 9, what do we need over here to turn this multiplication into an 18?
A 2.
2. Okay. So we have candidate numbers. So let's do the first outer, inner, last, and see if we could finagle that back into this. What do I get with my first multiplication?
3x squared.
Which is what we need. What about my outer?
21 x.
9 times 3 is.
Oh wait, no, 27.
27x. Okay, and then inner gives me what?
2x.
Last gives me what?
18.
18, which is what we want. I'm just double checking, right? Like we were pretty confident that's going to come back out. That's why we chose the 3 and the x. And then we're confident about this. That's why we chose the 9 and the 2. But I just want to be extra sure. Is there a way I could maneuver these guys to give me a negative 25?
Yeah, so minus 27 and a plus 2.
Okay, so that means the minus needs to go where?
On the 9.
On the 9. And then that means the other one has to be plus. And also, then I just double checking. Yes, if you do a positive 2 and a negative 9, you do get a negative 18, which is exactly where we started off with. Nice. Okay, we're good to go. So in order to get a common denominator, let's see. We already have an x minus 9 and an x minus 9 in both of them. So we're good in that respect. Now, what is missing? What factor is missing on this guy that we're going to need to pick up?
A 3x plus 2.
3x plus 2. So watch, I'm going to do this. I'm going to copy this down. X plus 9, x minus 9. And you told me that we're missing a 3x plus 2. So let's multiply the top and the bottom by 3x plus 2. Got it on the top. Got it on the bottom right there. Okay. I'm going to copy this guy down first. X minus 4 in parentheses because I put numerators in parentheses. I put the numerator in parentheses. 3x plus 2, x minus 9. So what's missing on this guy right here?
X plus 9.
X plus 9. So we did an x plus 9 on the bottom, got to do an x plus 9 on the top. So now I'm going to erase these couple ones right here. give me room for what I'm about to do. So we have a common denominator. That was the name of the game, right? That was what I wanted. Now I could put the entire thing over the same denominator. And so here is my common denominator. And how you choose to write it, I'm just going to write it like this, 3x plus 2. X plus 9, x minus 9. That's the common denominator in both of those guys, okay? Now, what I'm going to do is take this guy right here, 7 times 3x plus 2, minus all of this stuff right here, x minus 4, x plus 9. Now, okay, here's the thing. Here's another little trick. Whenever you have an expression like this, and you're using minus in front of something like this, something that you know you're gonna have to FOIL it out, right? Do this. Go ahead and just put brackets right here. That's gonna make your life so much easier because it's easy to lose sight of that guy right there. And to remember that every single thing that shows up here, you're going to need to subtract off. But putting those parentheses there can really help you out. So, okay, this is my new expression. Remember, in every single case, we want to simplify. So what are we going to have to do in order to reach that end?
I guess start by factoring, or not factoring, but like the opposite.
The opposite, yeah, the inverse factoring, multiplying it out. We usually I say multiply it out.
Okay.
I think that's what most people say. But yeah, inverse factoring, right? We're gonna want the hope, because like right now, if it turned out to be the case that I had a common factor, like an x plus 9 in both of these, then I could pull it out and cancel it out. But the thing is, like the way that we did this, we didn't go overkill, right? And the first denominator was deficient by one thing, and so we added that in. The second denominator was deficient by one thing, so we added it in. It's unlikely that we went overboard and now we could pull something out. So really the only thing we could do is multiply everything out. So what happened? So I'm just going to copy this down exactly. Okay, the first thing multiplies out to what?
21 x.
Yep.
Plus 14.
Now watch what I'm going to do. Big old brackets, and we're going to take care of that guy later. Minus all of that stuff. So let's do that. What do we get when we do this multiplication?
So x squared. Plus 9x. Minus 4x. And then 30 minus 36.
Minus what? Yeah, you said it. I think you said 36. It sounded like you said 76. And I was like, and I had to do my trick with my fingers and like, oh, okay, yeah, okay. Okay, so what does the middle part work out to?
Plus 5x.
Plus 5x. Okay, plus 5x. Now this is why, if this were just a plus, I wouldn't have bothered with this because it would have been plus each one of these guys, no difference. But since it's a minus, I don't want to forget that I'm going to have to subtract off each of these guys. Or in other words, that the minus has to distribute into each one of these terms. Brackets are your best friend. Parentheses and brackets are your best friend in this case. So let's distribute that minus into there. We have, first off, let's go ahead and do my 3x plus 2, my x plus 9, and my x minus 9. The first guys didn't change, 21x plus 14. Now let's distribute that negative, and what do we get?
Hold up. Okay. Minus 21x plus 14 minus x squared
Okay.
minus 5x
Yep.
and then plus 36.
Now the hope is, I see this is a quadratic, right? This is a negative something. So maybe I could rearrange this guy and it'll turn into something that maybe can factor out and cancel some of these guys out. I don't know. So let's do that. So I'm going to write it like this. I'm going to copy down the denominator. I'm not using my brain at this point. I'm just copying down the symbols I see. And now, okay, I have a negative x squared. I like to put the x squared at the beginning. So negative x squared. What about my x's? What do I have?
1 plus 5. So 26 x. Yeah, no, minus x. So the 20. Hold up.
I know. I'm trying to do it.
16x.
You say what? What teams?
16.
16. Yes. Plus 16x. Okay. And then finally, what do we have?
50.
50. Yeah, because 40 and then 10 is 50 plus 50. Now here's the problem. You see that negative in front of the x squared? We don't like that negative in front of the x squared. We like to have our leading term, the highest order term, to be a positive number. That's how we've always done this, and that's how we're, going to continue to do it. And so we are going to need to factor out that negative. 3x plus 2, x plus 9, x minus 9. Now, if I factor out a negative from the top, what am I left over with up here?
Hold on, I'm writing it down.
Okay, yeah.
Okay, so you have an x squared,
Yes.
a minus 16x, and a minus 50.
Minus 50. Good. Now, that's a thing we could factor. That negative is going to stay out front, right? And then it's going to, as I like to say, come along for the ride.
Mm-hmm.
And so I'm going to go ahead and write the denominator. Again, the hope is, man, maybe one of these guys shows up in the top. It's like the same thing I was doing with the denominator at the beginning. It's like that ugly thing we had, 3x squared minus 25x minus 18. I could spend all day trying to figure out how to do that. But then it's like, well, hopefully one of them is a 9. And it turned out, yeah, indeed, one of them was a 9. So I'm hoping that one of these factors is how we factor that guy right there. The problem is it's not, is it? Because we have a 50. 50 is not divisible by 9. 50 is divisible by 2. We'd have a 25 and a 2 maybe. No, okay. So sometimes it works, sometimes it doesn't. And it looks like it's not going to work in this case. So whatever. Let's see if we could factor it. We might not be able to. It might not be factorable. We'll see though. If it is factorable, what is the first going to have to be?
X.
X's. It has to be. Okay. Now let's break up 50. 50 equals 1 times 50. 1 and 50 are not going to give me 16. 50 equals 2 times 25. 2 and 25 are not going to give me 16. 50 is 4, and that's a 5. So a 2 and a 5, a 4 times. Wait. No, it's not 4 times anything. We would have done that. Well, it's 2 times 5 times 5. So 10 and 5. 10 and 5. Yeah, 10 times 5 is 50. 10 and 5 are not going to give me 16. So it looks like we're done. I think that's not factorable.
That's annoying.
Okay, so we're in agreement. This would be our answer right here. Notice that I did stop and check, right? I stopped and checked because I was hoping maybe something will cancel out. Once I saw that 9 wasn't going to work, and I saw that, well, you're not going to get a 3x and a 2 out of this guy, we could have just stopped. And if you're pressed for time, just stop. Like,
Okay.
but yeah, still, right? Like, do give it some thought. If you have time to go back and check, it turns out this guy does not factor at all. And so, okay, big deal. Okay, that's all I wanted to say with that. But that's the idea with each one of these guys. And I did want to go through that because you always want to check to see if something cancels on the top and the bottom. Okay, moving on. Okay, I really want to go into section 6.4 and 6.5. And you're going to say, we didn't do 6.5. You said we're not going to do 6.5. And that's right, we didn't. And we don't need to because 6.5 is 6.4, right? Remember, 6.4 was polynomial long division, where we learned how to take two polynomials, use long division in order to get an answer. 6.5 was synthetic division, which I said, screw it, you don't need to even think about it. The reason why is because it's a different algorithm. So knowing polynomial long division, you have an algorithm. In order to do synthetic division, you have to know a new algorithm. And on top of that, you have to know when you can and can't use it. So that's, you either learn 3 things and try to keep those in your head, or you learn one thing that works every single time. Use the one thing that works every single time. You end up spending an extra 20 seconds doing it. Big whoop, right? I think it's much better to just do the one way. So on your quiz, I will give you something like this. It will look, so we're looking at number 15 from 6.4. I will give it to you like this. Put it up here. 4x to the 4th minus 5x squared plus 2x minus 10 divided by 2x minus 3. Make sure I got that right. 4 minus 5, 2, 4 minus 5, 2 minus 10, 2 minus 3. Got it. Okay. I will give it to you like this and tell you, using polynomial long division, compute or calculate or whatever. That's how you're going to see it. And what I expect from there is that you then draw this guy. And what do we put under here?
The numerator.
And you tell me what to write.
Hold on. 4x to the 4th minus 5x squared.
Oh.
No?
Ooh. Remember, when we do these, we have to account for every power of x.
Oh gosh.
Yeah, that's the trick. That's the trickiest part about this. And so we don't have any x cubed terms, so we're going to go plus 0x cubed. Now, what do I write?
Minus 5x squared
There we go.
plus 2x.
There we go.
Minus 10?
Minus 10. There There we go. So you're absolutely right. We just put the numerator down there. The only trick is we have to account for the missing terms. Otherwise, I mean, you don't have to, but you're gonna have a hard time keeping everything straight, right? This is so that as we go and do this, all the stuff comes out in nice, nifty columns and we don't have to realign anything, right? So this is for our benefit. Now, what do I put on the outside here?
2x minus 3.
Okay, 2x minus 3. Now, what do we do?
Well, now you start dividing. And then, so you put the 2x into the 4x to the 4th, right?
Well, yeah, I mean, however you like to think about it. That's one way we could do it. I like that. And so what should I put up right here?
2x squared, I think.
Squared? Let's try. Let's see what happens if I do 2x squared.
Oh, no, wait, hold up. What do you just do to the 4th?
Well, first off here, let's do it this way. Let's say that we thought it was 2x squared. The next step, remember, is to take this thing, whatever we wrote right up here, and multiply it by this guy right here. When we do that, we get the 2 times 2 is 4. And then the x squared times the x is what?
X to the 3rd.
X squared times x is what?
Hold up. What?
So x squared times x is how many x's total?
3.
3. Is 3 equal to 4?
No.
No. So if we did this, we would have this right here.
Oh, I see.
It would not cancel. I really wanted to go through. The best way to learn is to do it the wrong way. Like now I can see why that wouldn't work, right? Like, and this is the whole point of what we're doing. Whatever we put right here is going to get multiplied by there. We're going to put that right here, and that has to cancel that guy out. And I can see that we're deficient. We don't have enough x's if I do x squared. And so what do I need? X to what power will give me the right number of x's?
X to the 3rd.
X to the 3rd. There we go. Now let's do it. So the 2 comes down, hits the 2 and gives me a 4. The x cubed comes down, hits the x and gives me a what?
4x to the 4th.
4th. Now we distribute this guy in, and 2x to the 3rd times this gives me what?
6x to the 3rd.
Is it positive or negative?
Well, it's negative.
Negative 6x to the 3rd. There we go. Then we subtract that guy off. I've used my parentheses because, well, not because of this, but because parentheses are our best friend in this case. And I could see, yeah, and this, remember, this is our check to make sure that we're doing it the right way. This should always exactly cancel that guy out. I have a positive 4x to the 4th minus a positive 4x to the 4th. They are gone. Now I have 0 minus a minus. What am I left with?
Well, positive 6x cubed.
Cubed. There we go. There we go. That's why I use the parentheses to keep myself honest, to remind myself that minus has to distribute in. And a minus is a positive, and then we do that. Okay, now I'm going to drop everybody else. X squared plus 2x minus 10. Now, what do I need to multiply this guy by to give me this guy? Or conversely, you could just divide one by the other and get your answer.
3x squared.
Plus 3x squared, and let's see if you're right. 3x squared times 2. So I do the constants first. 3 times 2 is 6. Good. X squared with another x makes 3 x's. Good to go. Now, this guy hits that guy, and what am I left with?
minus 9x squared.
Minus 9x squared. And so minus that guy off. The 6x cubed and the 6x cubed are gone. Okay, so I check. That's a check. I know I'm on the right track. Now, minus 5x squared. And that gives me what?
4x squared.
I believe so. Yes, positive 4x squared plus 2x minus 10. Okay. Now what do I do?
You do the 2x into the 4x squared, so you get a 2x.
So if I put a plus 2x on the top, let's see what happens. 2x times 2x gives me a 4. The 2 times 2 gives me a 4. The x and the x give me an x squared. And then what do I get?
8x. Oh wait, sorry, I went ahead. 2x times minus 3 is minus 6x.
6x, and then I subtract that guy off. The 4x squared is good, and I'm left with you just said it. What is it?
8x.
X, dropping the minus 10. The 8x minus 10 right there. Now what do I need to put right now?
Plus 4.
Plus 4 should do it. Let's check and see. Plus 4. 4 times 2 is 8, so that gives me an 8x. Yep, 8x. And 4 and the 3 gives me a what?
Minus 12.
Minus 12. And then when I subtract that off from that, I get what?
2.
Positive 2. Yeah, because that's a negative negative. That's positive 12 minus 10 is a positive 2. Okay, now here's the thing. There's my remainder. We can't go anymore, right? We have an x. You can't, well, you could, but we're not going to go there. Right now, our algorithm terminates and we are done, but we're not done because that's not what I'm looking for. What I want is the answer. I want to know this equals what? Well, it equals the thing that you got, right? So I'm going to say this equals that, but that's not it, is it? There's a remainder, right?
Mm-hmm.
And so how do we write that remainder all here nice and so we have the 2x plus 4. Now what? Plus something.
I think it's don't you do the 2 over the 2x minus 3 or something?
There it is. It's that easy. It's that easy, and that's always the case. If you ended up with a, so pay attention. If in the end you ended up, your remainder was say, oh, I don't know, negative 7/3. In the end, you would say, well, it's plus negative 7/3 over 2x minus 3. And that would be perfectly fine. You don't need to like manipulate that or anything like that. All I'm looking for is you take whatever the remainder is, positive or negative, I don't care, rational, whole number, whatever, you put it right there, divide by whatever the original denominator was, and that is what your answer should look like. Since our remainder was 2, a positive 2, I put a positive 2 in the numerator, divide by whatever that original denominator was, and that is the answer I'm looking for with this question right there. Does that make sense?
Yeah.
Any questions with that?
No.
Okay. I want to do a hard one, like, because these polynomial long division is so dang important. I'm erasing all this, sorry. This is, believe it or not, comes back so often and in so many places that you wouldn't expect, that I want to make sure that we're good at it. So let's say we have this. Let's go -1. Okay, now Let's say I tell you, this divided by this, using polynomial long division, compute that guy right there. What are you going to do? What are you going to write?
X cubed.
Uh-huh.
Hold on, I'm gonna write it down on my paper. So plus x plus 1 over, what is it, 2x minus 1. Okay, so you have x cubed and then plus 0x squared
Good.
plus x
Yep.
plus 1.
Yep. And now what goes on the outside?
2x minus 1.
Minus 1. Okay, now what do we do?
Oh boy.
We know what the goal is. We know that we're going to take some number, multiply it right here. And then whatever that times that is has to give me an x cubed. So let's take care of that numerator, or let's take care of the constant term first. What can I multiply 2 by in order to give me, in this case, 1? Give you a hint, it's not a whole number.
The 1/2.
1/2, exactly. In other words, whatever number this is, we want to get rid of it. So it's got to go down into the denominator. And whatever number we want to end up with, in this case, it's 1, has to be in the numerator. So that's what I'm going to guess. I'm going to say, well, I need to kill the 2, right? I need to kill that 2. The only way to kill the 2 is to divide by it. That's what we're doing here. Okay. Now, how many x's do I need in order to give me the correct thing?
X squared.
Yes, 1/2 x squared. Now let's just check and see if that works. So we just got to this point, and now we're checking that when we multiply this guy through, we do get the thing that we want. So we did the constants first. That's how I like to do it. 1/2 times 2 gives me what?
1.
1, as it should. The x squared times the x gives me what?
X cubed.
Which is exactly what we want. So now I feel confident that I put the right thing on the top. So now that hits that and gives me what?
A minus 1/2 x squared.
1/2 x squared. Okay, so I subtract these off, and what do I get?
1/2 x squared.
That's all that's left because we did the thing correctly. Oops. We did the thing correctly and it killed the cubed term. And so, okay. Now, what do I need to multiply this guy by to give me that guy right there?
One quarter.
Good. Excellent. Excellent. Yes. Yeah, exactly. Because I could see, well, 2's got to die, so we have to get a 2 in the denominator. And then I need another 2 in the denominator. It's the same thing as 2 2's in the denominator, or 1/4. That's my guess. So I'm hoping that that'll work out. We'll have a chance to check in a second. How many x's do I need?
1.
1x. So 1/4 x. All right, we'll try that. Now, that looks like it should do it. Let's do it. So I'm going to put my parentheses right here. Let's do the constant term first. 2 times 1/4 gives me what?
Boy. 1/2.
1/2. And it had better. It had better do that, right? Like that was the whole point. And now I can double check and see, now I feel confident, like, yeah, that's the correct thing, because when I do this, I get that. Okay, and so that gives me 1/2 the x times the x gives me an x squared. And now I have what?
Minus 1/4 x.
Minus 1/4 x. I subtract them off, and what do I have?
1/2 x. No.
Yeah, because it's a plus. All right, the minus is a plus. I'm just kind of filling in the blanks because we know it's going to be an x. It's just a matter of how many x's do we have.
2.
1, and then it's plus 1/4. What is that?
1 1/4.
1 1/4.
Or 5/4, I guess.
5/4. There we go. All right, because I'm thinking 1 plus 1/4 is the same thing as 4/4 plus 1/4. And so that would be a total of 5/4. And so 5/4 x. Okay, it's the last step right here. And this is easily the hardest part of all of this. Because now we need to multiply 2 by something to give me 5/4. So I'm thinking 2 times some number equals 5/4. So what you could do is just divide both sides by 2. This is the thing, right? So this is the thing we're looking for. 2 times what number gives me 5/4? 2, in other words, 2 times z equals 5/4, and we're trying to solve for z. What do I do in order to get z by itself?
You divide by 2.
Divide both sides by 2. Like we talked about earlier, there's a couple different ways we could write divide by 2. And I'm going to think about it as we'll multiply by 1/2. Five times 1 is 5. What do I have in the denominator?
8.
8. That's my candidate. I think that might be it. I think that's what I want to put up here. Let's check. Now, how many x's do I need?
0.
0 of them, yeah. So, okay. 5/8 then goes into there. Now let's just check. 5/8 times 2x. So 5/8 times 2x is what?
5/4.
Yeah, because the 2 will kill that guy, leaving me a 4. And so we do get 5/4 x. And then what?
And then you multiply the 5/8 by the -1, you just get minus 5/8.
Minus 5/8. Okay, the 5/4 is gone by design. That's why we did it. We needed that 5/4 gone. And now what's left? One plus something.
1 plus 5/8.
Which is what?
6/8. No. Hold up. 8 plus 5 is 13. 13/8.
13/8. Okay, now finally we have this plus 13/8. That's my remainder. That is my remainder right there. And so You tell me what to write, because this is all I'm looking for, really. Like, is the final thing. We're saying that this divided by this is the same thing as what?
Plus, okay, so it's 1/2 x squared plus 1/4 x plus 5/8 plus 13/8 over 2x minus 1.
Perfect. That is exactly what I'd be looking for in this case. That is exactly what I'm looking for, right? We don't need to use our brain. We don't need to be tricky about this. We don't need to put the 8 in the denominator or try to factor anything. This is exactly what I'm looking for. Whatever your remainder is, you put it in the numerator of that very last term, and you divide by whatever the original denominator was. And that is equivalent. That means exactly the same thing as that right there. Just so you know, one of the reasons why this is so good to know and have in your head is in calculus, you do something called integration. And you're going to be eventually given something called an integral. Let's say, take the integral of this. It means like do this operation to this thing. And if you tried to do it to this, it's going to take you a couple days to realize that you can't after you've hit it with everything you possibly can. But if you go, oh, wait, I can rewrite this like this, and you're done in like 2 seconds.
Mm-hmm.
So it shows, that's one way that it shows up and is really useful. And it's really good to know that you could take something like this and just divide it, literally use this algorithm to get something like this. And this is much nicer than that right there. So, okay. That's all I wanted to talk about with that. I mean, everything else, like I said, go over this review. This is all stuff that we've done. The chapter wrap up. Yeah, that's what I mean. Go over the chapter wrap up. And is there anything you want to ask? Any questions you had or any sections you were struggling with or anything like that?